Hello everyone. Myself Dr. Anju Mishra. I am Associate Professor in the Department of Information Technology, Akgec Engineering College. And today we are going to uh, discuss over the topic of Hyperledger Fabric, which is part of the blockchain technology. So as we already know that the blockchain technology mainly consists of three components. So we are having a distributed ledger, we are having a consensus algorithm, and we have the smart contracts. So when we talk about the blockchain technology, we all know that blockchain is nothing but a distributed environment or a network where multiple parties they can join, and whatever transactions are happening between or among those parties, those can be recorded in a very transparent way. Now, when we talk about the blockchain technology, this technology is very popular and is being used in a wide variety of applications. So, for example, in healthcare and in the finance sector, uh, like that, we are going to use the blockchain technology. Why this technology is popular? Because it provides us with high security and transparency. And one of the things is that this technology is robust and maintains the data or the logs about the transaction in a very robust way. So the technology mainly consists of the distributed ledger, and we already know that distributed ledger is the one entity where all the data related to the different transactions that are happening over the network, blockchain network, that is being recorded, right? And a copy of this, distributed ledger is being maintained in the local memory of each and every particular node, which is part of that blockchain network. Then we have the next component, which is called as the consensus algorithm, and this is the mechanism by which the whole network actually comes to an agreement over the validity of the different transactions. So, for example, if some certain operation is being initiated by a party or by a node or by a user attached to the distributed network, now this transaction or this operation needs to be verified by the peer nodes or by the different nodes that are part of that blockchain network. So consensus algorithm is the mechanism that brings this uh, validity of operations and the transactions into the network. And when we know that in a distributed environment it is hard to achieve the agreement, because every party is having their own kind of perception. So the beauty of blockchain technology is that the different nodes which are having their own perspective, right? They are coming to some agreement, and they are thereby validating the transactions and the operations. Once a transaction is going to be validated, as a result of that, certain smart contracts, those are being executed. So smart contracts are nothing but a piece of code that is going to be executed as a result of a particular transaction. And once the transaction is verified, of course, and these smart contracts, they have been implemented for implementing the organizational policies and all, right? So today we are going to discuss about one of the important technology of the blockchain, which is called as the Hyperledger, because we know that there are different types of blockchain networks. We have private blockchains, we have uh, public blockchains, and we have the third type of blockchain, which is called as a consortium blockchains. So when we talk about the Hyperledger, this is an advanced technology, and it is basically a use case of the blockchain technology. This Hyperledger project was first of all devised by the Linux Foundation around in December 2015. And when we say that what is the requirement of this Hyperledger environment, we can say that this actually is providing a platform where different parties can collaborate together and they can implement their own, kind of private blockchains. So one of the basic difference between a Hyperledger and a, blockchain network is that Hyperledger allows to create multiple private blockchains, okay, over a single network, right? So we must, keep into our mind that when we are talking about the Hyperledger technology, it is neither a cryptocurrency like the Bitcoin, nor it is, kind of environment like Ethereum. Okay, rather it is a kind of platform which on which you can, implement your own personal, blockchains for to be used into your own applications. Now, there are many, different types of applications where we can use, the Hyperledger technology. So, ranging from the supply chains in the market, from the trade finance, loyalty and rewards, for implementation of settlement of financial assets. So, these are some of the, application areas where we can, implement this Hyperledger technology. And it is basically a repository which is created for creating multiple blockchains, blockchain networks on a single network. Now, how the implementation is being, proceeded for the Hyperledger, that is, kind of dependent on the manufacturer or the implementer. So there are variety of Hyperledger, platforms that have been developed, and some of the examples are, for example, this IBM Hyperledger Fabric that we have, right? In today's lecture, we will explore this Hyperledger Fabric developed by IBM. But apart from this, there are other, Hyperledger platforms, like, for example, Hyperledger Indies there. Then Burrow is another, such platform. Sawtooth is another popular Hyperledger, platform that we have with us, through which we can create those, end-to-end pipelines between the, the clients and the service providers. So those blockchains could be developed over these of the networks. Now, when we talk about the Fabric, first of all, we need to know that Fabric is the platform which is being developed by IBM, and it is being maintained as an open source, project by the IBM. And some of the characteristics of Fabric is that it is a permissioned blockchain framework, right? So it is not, public fully, as in case of a normal public, blockchain technology, where as a user I can join in anytime and I can have access to the network and its resources, right? So on the Hyperledger Fabric, we are only allowed to create the permissioned blockchains. And why we need this kind of, functionality here? Because for example, if I am a supplier of certain goods, there could be, specific users or the customers for my, productions or my items, for example. So I don't want to, expose all the details of my business to anyone, right? I want my business to be between me and the parties which are involved into my business. So, for example, there could be suppliers of raw materials, there could be, intermediate traders, there could be the end users or the customers. So, I'm only, allowing those details to be exposed to the relevant parties only. So that way, I need certain kind of a permissioned, blockchain. And next thing is, this Fabric is basically a modular, architecture. So most of the, components, they can be interchanged when you are developing your blockchains. So what you can do, for example, that once we are, implementing a normal blockchain technology, we are fixing up the components, like, for example, the consensus algorithm you are choosing. That consensus algorithm may be the proof of work, or it could be proof of stake, for example. And once you fix that, you have to go through that consensus, mechanism only, right? So there is nothing like that. For example, later on, if I want to, change that particular mechanism and I want to implement something new into my existing blockchain, whole of the architecture needs to be revised, right? So this type of flexibility has been provided by this fabric, network, and it is modular. So we are having components that can be, changed, and we will be able to, apply a new type of consensus, mechanism as and when we required into our system. So we are able to, kind of, plugging new, components and replacing them, replacing the older ones with the new ones. So this is called as the plug and play, facility, which is there. Another aspect of Hyperledger Fabric implementation is that for example, we are going to have multiple blockchains over a single network. So for example, if I am having a network like this is the Hyperledger, Fabric platform. I can create end-to-end, blockchains here, which are of course permissioned. Now, for example, these blockchains, they are including multiple parties, and sometimes we want that even whatever transaction is happening between me and the supplier of the raw material should not be visible to any other party. So it is fairly possible, and this concept is being supported with the help of the concept of the channels. So different channels we can create in Hyperledger Fabric, through which we can restrict that who can have the access to use a particular type of data or the transactions. The next important aspect is that Hyperledger Fabric is general purpose framework. So you can use it as per your own convenience and as per your own problem domain. It offers identity management, so it is of course possible always to identify a specific entity. So for example, I will be able to identify which users are part of a certain blockchain. So this type of identity management is crucial, because we need to validate that what kind of data belongs to what kind, which blockchain network, and that data should not be accessible to any other different blockchain. So to keep that data segregated, this identity management is helping us into that. And the last thing is the access control features. So as I told you, that by applying certain kind of identity to each and every component into the network, the access control is being facilitated. So who is going to see what, that will be decided totally by the authority of that particular network. Now, the fabric is basically designed to support the pluggable implementation or different components. So as I already have mentioned to you, that with Hyperledger Fabric, we are having the flexibility of including or replacing the existing components and including new components as and when we require it. So for example, the membership services, if we want to add on some more, or we want to replace certain existing ones, that we can simply plug in, and through that functionality will be implemented into your blockchain network. The next thing is that the user it uses the container technology to host the smart contracts onto the network, and these smart contracts are nothing but the chain codes. So what is a chain code? So chain code, they are specifically written in a certain programming language which is compatible with these blockchain development environment. And once you write that chain code, it essentially implements the organizational policies into your blockchain network. So for example, if you have created a blockchain, and for example, for certain operation, if it is done correctly, or how many transactions you have validated as a peer node, based on that, certain reward needs to be given to you. So this is not going to be done manually, rather it will be implemented as a chain code, and those policies will be enforced whenever the criteria or the condition is going to be automatically satisfied into the blockchain network. Now we are going to discuss next that how this Hyperledger Fabric work. So when we talk about the working, the network contains different types of entities, and we need to know what each and every entity is there for. So for example, the first thing is that there are member nodes which are connected to the Hyperledger Fabric network or the blockchain which you have created over the network, and these are called as the unique organizations. So unique organizations are the parties which are having their own private blockchains, and those are interacting together. For example, as the suppliers or the customers, they are interacting together, and the business is going to be run. For example, the unique organization could be a bank in a network, which is comprising of different types of financial institutions, or it could be a shipping party if we are talking about a supply chain network. Now, each of these organizations is having a fabric certificate authority. So this is important to know that when we are talking about the unique identity, maintaining the unique identity, or uniquely identifying each and every component of of the blockchain networks, that is actually facilitated with the help of this fabric certification authority. And every organization in the network is going to have one such fabric certificate authority, and there will be one or more peer nodes which are attached to the networks, right? So these peer nodes, what they do, that we are going to see in a moment. So these are the components that we need to keep in mind. Apart from this, the network is going to have an ordering service. So ordering service is again a standalone active entity which is there, and this ordering service is basically a shared service which is being shared among the parties which are part of that particular network, blockchain network. Now, when we are implementing this Hyperledger Fabric network, where we are starting from. So for example, your nodes are already part of the network and you have implemented it. Now, first of all, the identity management needs to be done, and this is going to be done with the help of issuance of the certificates, right? Now, these certificates are of different types. So as you can see, one of the most important certificates are called as the root certificates, and these root certificates belongs to the organization itself. So now your organization will be identified with the help of a root certificate. Why we require root certificate? So because Hyperledger is a platform where multiple blockchains will be developed or be running, right? So to identify that which organization or which blockchain we are talking about at this moment, that will be identified with the help of the root certificate. And of course, there will be the users and the peer nodes in that organization, and we are sometimes interested in identifying those nodes, the peer nodes and the users. So while the transactions are going to be committed or verifying by the peer nodes, we need to know the identity of those nodes so that we are ensured that okay, these are the authenticated nodes which from which the endorsements needs to be counted, right? So whether the endorsements are valid and they should be used for the verification of a specific transactions or the operations, the peer node identity must be there. So for this purpose, the users and the peer node, they are also being issued certain certificates for defining their identity, and these certificates are derived from the root certificate, because multiple networks will be there on the Hyperledger platform. So which user and which are the peer nodes which are part of a specific organization, that will be identified, that who is the the original or who is the owning authority of these users and the peer nodes. So for that, these user and the peer node certificates, they are derived from the root certificate. Now, these certificates also specify the permissions for the access control. So how much data the users can access, how much transaction log the peer nodes can access, that will be totally defined by these certificates permission part. Now, the root certificate for the organization is going to be stored with the certificate authority, which is called as the CA. So the Fabric certificate authority is the one entity which stores all of the organization's root certificates. Now this Fabric CA issues the certificates for the users in the organization and handles other related operations, for example verifying the users and the peer nodes, etc. Now when we are talking about an enterprise grade Fabric CA, it utilizes a variety of components and can be deployed in a variety of ways. Now for example, this CA can be implemented with the help of a hardware security module for root certificate protection. When we are talking about the organization, so the certificates are being issued and there are one or more peer nodes that carry out different types of operations on behalf of the organizations. So these peer nodes are nothing but the leaders or the verifying nodes that are doing the verification of the user transactions and operations on behalf of the organization. So that is the purpose of creating the peer nodes into the Hyperledger Fabric. Now specifically a single peer node endorses the transactions which are proposed on the network. It stores and executes the smart contracts code, which are called as the chain codes in Fabric terms. And thirdly, it stores a local copy of the ledger for access purpose, right? And client are not directly interacting with the network. Rather, they use these peer nodes and they interact with the peer nodes and they read the ledgers, and if they want to add new chain codes to the network or propose a new transaction, that needs to be through these peer nodes. So the interaction of clients is with the peer nodes most of the time, but yes, in the Hyperledger Fabric, there is another entity which is called as the ordering service. So this ordering service is another entity where the user is going to be interacted with, right? And why and when this ordering service is going to have the interactions with the users, that we are going to discuss when we will see the working. For now, we need to just know that most of the interactions will be with the peer nodes, and some of the interactions will be this ordering service. Now, as I already have mentioned, that the ordering service is being shared by all of the members of the network. This entity is responsible for new transactions on the networks. Are they properly ordered into the blocks, or are those transactions are having proper or enough number of endorsements from the peer nodes? So the ordering service is there in the Hyperledger Fabric to verify each and every transaction and checking whether those transactions are being ordered in a proper way or not. So whether your block is ordered properly or not, this is the working of the service, this ordering service. And another thing is that when a transaction or operation is going to be verified by the peer nodes, the user requires certain number of endorsements from different peers. So if k number of endorsements are with the user, then only the user can broadcast that particular block or the new transaction, and it can propose it to the ordering service. So another aspect of ordering service is to ensure that all those transactions that have been received to it for further verification, those are having proper endorsements from the valid peer nodes, and enough number of or k number of endorsements are there for each and every transactions for their validity. The ordering service broadcasts a new block of transaction to the peer nodes in each organization, and the peer nodes are then going to update their local copy of the ledger. So this way the transaction commits are there into the Fabric network. So this is one of the example of the Amazon blockchain technology which has been implemented. So this is the Hyperledger Fabric, which is being underlined in the Amazon services. And as you can see, there are different types of peer nodes some are endorsers, some are anchor nodes, some are journal pairs, and there is a company called A, then there is another company, company B. These two are the communicating parties here, and the business is going to be done between these two. So now the blockchain is having these two organizations, both are having their own root certificates with them, and company A is actually having certain clients, and those clients are interacting with the peer nodes. So once a user poses a new transaction that is going to the peer node for verification, the peer verifies that transaction, and once the transaction is being verified, and it is going to send back an endorsement to the user. So once the k number of endorsements are being received by a specific user, the user is announcing to the ordering peer that these transactions has been happening, right? Now ordering peer or the ordering service is the one entity which is again checking all those transactions and seeing whether those transactions are in proper order or not, and whether those endorsements are correct or not. So after checking it, the ordering service is going to announce back that a new block has been created, and thereby each and every peer node is updating their own local copy of the distributed ledger. So that way the whole mechanism is going to be done. So in this diagram you can see the workflow here. So client submits the transaction proposals to the peer nodes. Now these peer nodes, they are simulating the proposed transactions and sending these endorsements back to the client. Once the client receives these endorsements, now it sends these endorsements for checking to the ordering service. Once the ordering service receives it, it is actually checking whether a proper sequence is going to be maintained and enough number of endorsements are there, and then it is broadcasting the new block. If it is a verified block or it is a proper block, it is broadcasting those changes to each and every peer node. So thereby the peer node is making changes into their own local copy of the ledger. Now apart from the Hyperledger Fabric, there is another platform which is called as Hyperledger Sawtooth, and it is another open source blockchain platform which is hosted by the Linux Foundation. And there are certain changes or certain characteristical differences between these two platforms, as we can see into the table. If we talk about Hyperledger Fabric and Sawtooth, in terms of the permissions, it is a permission network. So basically the Hyperledger Fabric was originally designed to support only the permissioned blockchain networks, while Hyperledger Sawtooth is a platform which has been created for both type of blockchain networks. And privacy and network governance. So when it comes to the Fabric, it provides complete data isolation between set of participants with the concept of the channels, and strict network authentication is there with the help of the certification authority. So each and every node is being uniquely identified, and as well as the access control is there with the help of these certificates. In the Sawtooth, all the network peers, they have access to all transaction data, so everything is visible to everyone, and it does not have any kind of these certificate authority like CA and any kind of channel facilities. So your data is, whenever a transaction is happening, it will be visible to each and every one, right? And when we talk about the transaction flow, the Fabric follows the unique execute, order and commit endorsement model, while the Sawtooth uses the traditional one, which is the order, execute and commit flow. Now consensus algorithm and other component in Fabric, they are more flexible, because I already have told you that there is a plug and play kind of facility which is available with the Fabric network, so you can change those things. So pluggable consensus algorithm is one of the important aspect which is there in the Fabric, but in case of Sawtooth, we are only having a fixed kind of consensus mechanism, which is called as the proof of elapsed time, which is essentially a Byzantine fault tolerance, consensus mechanism. And when we talk about the implementation of the smart contracts in both of the platforms, we can see that Go, Java, Node.js, these are the popular programming languages which have been used to implement the smart contracts. In case of Sawtooth, Go, Java, Python, and Rust, these are the most popular, programming languages or implementation languages that have been used for implementing such networks or the smart contracts. And when we talk about the benefits of Fabric network, so we know that it is an open source, easily accessible. The second thing is that it is a strictly permissioned network. So whatever blockchains you are creating, your data will only be shared with the parties you agreed to share your data. The third thing is that the governance and the access control. So access control is there, so not everybody will be able to see everything, and that gives us some sense of privacy of data. And the last thing is that the performance of this network is increased. Why? Because the consensus mechanism used here can be changed, or it can be customizable. So since in Fabric we are not using, for example, the traditional Byzantine fault tolerance system, which is very costly to calculate, right? So every commit for a specific transaction or operation is going to take a lot of time, but in Fabric this could be not that time taking, because other kind of consensus mechanism are being used as per your own requirements. So kind of performance enhancement we can see when we are talking about the Hyperledger Fabric implementations. So this is all from my side today. Thank you so much.